use SOHCAHTOA. You know it's going to be in quadrant 3, so we're looking down here. So the triangle that we're creating is this triangle with theta here. Okay? And so if the tangent is opposite 6 over adjacent 7, what you can do is once you find that ratio, you need to assign the correct signs, positive or negative. So our x here in quadrant 3 is negative, and our y is also negative. Okay? And so that's going to be used for the information on that right triangle. I'm then going to find my hypotenuse. When I find my hypotenuse, it doesn't matter. You can use the negatives here, but it's going to wind up being a squared plus b squared. Again, even if you put -7 and -6 in grouping symbols, the square is going to take care of the sign. So you get 36 plus 49. And so when you combine those, you get 85, square root both sides. And so your hypotenuse is the square root of 85. So once you set up this Pythagorean theorem, or this right triangle using Pythagorean theorem, you can then find your missing pieces. Okay, so I have my tangent. I'm going to find my cosine. The cosine is here adjacent, -7, over hypotenuse, root 85. And so if I rationalize this, root 85 divided by 85. Again, you should be able to put -7 divided by root 85. That should work okay, but I'm going to go ahead and rationalize. My sine is opposite, -6 divided by root 85, which again would reduce to, or rationalize to, -6 root 85 all over 85. And then I can start finding my reciprocal ratios. My cotangent is just going to be 7 over 6. My cosecant, I'm going to flip this. Again, what I had here was the hypotenuse divided by the opposite side. Instead of writing my negative in the denominator, I'm going to move it in front. And then my secant is the reciprocal of cosine. So it's going to be root 85 divided by the -7. Move the negative sign in front. And so those would be my simplified forms. And now, I mentioned you can solve these using your calculator as well. If you are going to use your calculator to solve these, the method that you would use is you would find what the actual angle is. And so if you took the very first piece of information, the tangent of 6 over 7, and if I sort of reverse engineered that, meaning I'm going to solve for the angle, if you were to do that, you would say that theta is equal to the inverse tan of that ratio, 6 over 7. So if I use this and I identify what is the angle that I'm working with here, it doesn't matter whether you're in radians or degrees, right? Because you're going to use the same angle for each. Okay? So when I work to solve this, I can hit the cotangent. Well, that one we shouldn't need. We could do that one by ourselves. Let's do cosecant. So if I want the cosecant of this angle, I just highlight my measure and enter, and it gives me root 85 over 6. Now, notice it doesn't give you the sign, though, right? The sign you're going to have to identify in third quadrant. Again, when you're dealing with the cosecant, which has to do with the sign, it's a negative number. So if you are going to use a calculator, you have to use your own rules for the signs. Okay, if I wanted the cosine here, I can calculate that. The cosine of, go highlight my exact answer. Cosine is 7 root 85 over 85. And then again, cosine, make sure in the third quadrant is a negative number. Okay, and so you can use your calculator to evaluate each of those. I'm showing you how to do it by hand because I think it is easier to do by hand, or it's the same amount or faster. Using your calculator might be more accurate. Just be aware of how much time you have remaining to determine what you want to use. Okay, you're given the first quadrant. So if you're told it's in the first quadrant, you can sketch your right triangle there, identify or label your reference angle theta. Here, the cosecant is the reciprocal of sine, right? So you know that the sine of theta is going to be the reciprocal of this. And even though I'm going to rationalize that when I enter my answer here, so the sine is 8 root 113 over 113. When I set up my right triangle, I'm not. I'm going to use this form. So sine is opposite 8 over hypotenuse root 113. And so when I set up my Pythagorean theorem, I have a squared plus 8 squared is equal to root 113 squared. A squared plus 64 is equal to the radical and power cancel. And so when I'm simplifying what I have here, I subtract 64 from both sides. Extract the square root. I get a is equal to plus or minus 7. So when I set this up here, I know my x coordinate is positive, my y coordinate also positive. And so when I set this up, or when I work to solve this, I'll get my solutions here. And so when I plug those in, my cosine is adjacent over hypotenuse, so I'm going to rationalize. So 7 root 113 over 113. My tangent is going to be opposite over adjacent, so 8 over 7. I'm going to go ahead and flip that for my cotangent, 7 over 8. And my secant is the reciprocal of cosine, so that's going to be root 113 divided by my adjacent 7. And those would be my solutions.